So why do we need Java optional? Let's take a look at the code on the screen. You see that there is a user factory class which has a method to return a user based on some logic, maybe fetching from the database. The problem here, of course, is that this returned user object can be null. The way the caller would call the user factory is to call it and then check for the return object to be null. If it is not null, then proceed to process the user. If the null check is not there, as you notice in the example, your application could throw a null pointer exception. The sad reality is that in many cases, the developers forget to check for null. And that's the reason the null pointer exception is the most common exception. So the question now is, how can the programmer who coded the getUser API convey to the caller that null is a valid return type and that the caller should handle it? That's what Java optional class is all about. Java optional types make sure that the caller of the API is forced to think about null as a return value. This way, null pointer exceptions are avoided. It's of course entirely possible for the developer to bypass this recommendation by the API creator, as we will soon see. But then it will be a conscious decision by the caller. So let's begin with what is an optional data type. The optional type is a container for the actual object that needs to be returned. The name of the class itself is called optional, and it can be used as a parameterized type, which means that it can contain any kind of object, any type. The big idea here is that if a method needs to return a value which can be null, then that method could instead return an optional with the value embedded inside it. Such a method must never return a null. When we think about optional types, it's useful to think from two different perspectives: creating an optional object and consuming an optional object. The API or method writer will be more interested in creating the optional and returning it back, whereas the API caller will be more interested in how to consume the returned optional. So let's start with some methods which are useful for creating an object of type optional. The first example here is the creation of an optional object from a non-null value. The way to do this is to use the static off method in the optional class. We need to be careful here because the value passed to the off method must not be null. Otherwise, we are going to get a null pointer exception, the very outcome that we want to avoid in the first place. But what if we explicitly want to convey that the value returned is null? Remember, when we use Java optional, we don't ever return a null, but we return an empty optional, an optional with an empty value. The example code on the screen shows how to create an empty optional by simply calling the static optional.empty method. What if we do not know whether the value is null or not? Maybe we retrieved it by calling another method and we cannot be sure. That's the third way as demonstrated on the screen. We are using the offNullable method here. It's actually safer to use offNullable method rather than off method because it's sure to take care of the null. Now that's the first rule. When in doubt, use optional.offNullable instead of optional.off. That is sure to take care of the nulls. Now let's take a look at some of the ways to consume the optional object. When the caller calls the API and gets an optional object, how does the caller handle this optional? If you want to check if a value is present in the optional, then use the method isPresent. That's what you see on the screen, the isPresent being used. If you want to check if the optional is empty, use the method isEmpty. Simple. So those two methods are actually sufficient to make use of the optionals. Of course, there are better ways, but these two are sufficient. With this knowledge under our belt, let's now rewrite our factory method, the user factory method, which we had seen earlier, to use Java optional instead. This should be straightforward. You can now see that in the getUser method, offNullable is used to return the user object wrapped in an optional type. But note here that if we know for a fact that the user can never be null, then we do not need to use the optional. Simply return the user. In this case, because the user could be null, we are returning an optional of type user. The caller, on the other hand, uses the isPresent method to determine if the optional has a valid user and acts accordingly. Now you might ask, how does this exactly improve the code? After all, you're still using the if. Notice that the caller is forced to use the isPresent and the get methods to get the actual user, and hence is forced to think about the null value. Having said that, the caller has the right to completely disregard this and do the following. Here you notice that the caller has simply called the get method without checking if the optional has a value associated with it or not. Now this is poor programming, and if you plan to do this for whatever reason, it's worthwhile documenting why you think the optional will always have a value. Otherwise, you will simply confuse other developers in your team. Now that's the second rule. Don't call the optional.get without checking if the value is present. Now let's take a look at another problem that can happen. Here you see the getUser method is actually returning an optional object which itself is null. This could be a bug in the system and it could happen because of some condition, but it's a disaster written all over. The whole point of optional use is to protect the calling code from null. By returning an optional object which itself is null, we have created a rather funny and ironic situation. And that's the third rule. Do not ever return a null as an optional. Return an empty optional object. Now, Java's optional class was designed to be used as a return type for methods. There is nothing, however, stopping developers from using optional type as parameters to a method or a member variable of a class. Now note that the optional type is actually not serializable, so it doesn't really belong as a member variable of a class, and it should be avoided. And in a similar way, optionals should not be used as parameters in a method. This leads to overuse of optional and leads to unreadable code. Using an optional for just return types for a method is a great balance. Now that's the fourth rule. Use optional type only as a return type and not as a method parameter or a member variable of a class. Now we know how to use a Java optional. We know what it is, how to create them, and how to use them. Optional class also has a number of functional and Fluent style methods that can be useful if you're a big fan of functional programming. The optional class contains multiple methods like map, filter, flat map, or else, which are useful for functional programming. In this video, we will explore the functional and Fluent style of programming with Java optional. On the screen, you see a simple example of a user record which has the following data attributes: user ID, name, address, and whether the user is the CEO. The address variable itself is another record which has an address line string and a zip code. Here's how the optional class can be used in our code. Consider that you are probably writing a reusable code which can be used by multiple developers, probably something like a library. In the example, you see that the users class has a method called getUser, which returns an optional of type user, indicating to the caller that the return type of the user can be null. Note that the optional value itself must never be null when you return it. How does the caller use this API? Here's one way. The caller of the users.getUser method uses the isPresent method of optional to check if a valid value is available, and if so, will process the user. And then of course use the get method of the optional to retrieve the actual name. The end benefit of using the optional class is that the caller is forced to think about handling the null return value. This prevents a null pointer exception and makes the code robust. In spirit, the idea is very similar to throwing a checked exception, which also forces the caller to handle that exception. But here I should caution you. The recommendation by Java engineers is to return Java optional when writing libraries which will be consumed by many developers. It's definitely not the intention to design every method call to return an optional where a null can be returned. As an example, libraries like Java Streams API return Java optional in many places, and so do Spring Boot libraries. Basically, we have talked about how Java optional can be used in an imperative style development. But let's now start looking at a more interesting case where we consume an optional in a functional style. Optional class provides a method called ifPresent, where the programmer can provide a lambda expression, a consumer in this case, to handle the contain object. On the screen, you can see the code is calling the ifPresent method and passes the consumer to handle the contained user object. Here, a lambda expression is passed for a consumer. However, if variable OUser is an empty optional, the consumer will not be invoked. In other words, it's a functional style of using the classic Java if statement. The method signature of ifPresent is also shown, which takes a consumer interface as input. As part of the typical Lambda programming, we can also pass a method reference instead of a Lambda expression. This makes the code more readable. In the example here, you can see that the method reference main : handle user is passed as a parameter so that the user handler code is isolated to a different method. That's a more readable design. But what if the caller wants to use the classic if then else statement? The caller wants to do something as part of the else. That's possible by using the method ifPresent or else method. Here's an example. If a user is available, then the first parameter, which is a method reference, is invoked. Otherwise, the second parameter, which is a lambda function representing a runnable, is called. This method, if present or else, is the functional equivalent of the classic if then else as applied to the optional object. Now, apart from these, the optional class also has a number of or else methods, which are useful to express what needs to be done when the optional is empty. Here's an example of using the or else method. Here, the user variable is assigned the contained value in OUser if it is available. Otherwise, the constant default underscore user is assigned to it. Now, this method is a functional equivalent to the Elvis operator, which we find in other languages, like Groovy. But what if the default user is not as simple as a constant, but needs to be retrieved as part of a different logic? Optional class has the or else get method, which can be used. Now, this is similar to or else method with the exception that when the optional OUser is empty, the supplier lambda function is called, which uses some internal logic to retrieve the default user. Now, there is also a similar OR method in optional, which also uses a supplier, but it supplies an optional of a user instead of the user. That's a subtle difference. Now, sometimes the user simply wants to throw an exception if the optional is empty. What can we do about that? We can use the or else throw method to return the user if available. Otherwise, simply throw the default no such element exception. But what if you want to throw a customized exception and not a no such element exception? Can we do that? We can use an overloaded method of or else throw where we pass a lambda expression as the parameter. And inside the lambda expression, we can throw whatever exception we want. It's basically a supplier of exceptions. But it gets even better from here. There are a number of methods in optional which are useful for a Fluent style development. Such methods return back another optional object so that more methods can be called on it, and thus creating a chain of methods. Without optionals, we cannot do Fluent style development because a return null would practically end that chain. The Fluent style of programming uses method chaining to express and implement a particular use case. We see this kind of programming when using Java streams, for example. The pseudocode for such a style looks something like the following on the screen, and it's easy to recognize this style. Now, there are many methods in optional like filter, map, flat map, which can be used for Fluent style development. The stream class also has similar methods. These methods are similar in spirit to the streams methods, but operate on the optional value. Let's take a look at each one of them. The map method translates the optional of one type to an optional of another type. Now look at the code on the screen which extracts the name of the user in an imperative style. That's using a typical if statement. In the code on the screen, we are getting the user object for the user ID UID and then extracting the name of that user. The variable name can be either null or a valid string. In the optional world, the perfect way to represent it is an optional string. So basically, our real requirement is to convert from optional of a user object to an optional of string which represents the name. The map method does that for us, as we show on the screen, by using a Fluent style. As you see, we can call the map method on the optional. The map method takes in a function which takes a user object and returns the user name. The method reference user : name is passed to represent that function. So here we used a much more Fluent API to extract the name, and the end result is quite pleasing to the eye. Let's now change the requirement a bit to say that we should only get a valid name if the user is the CEO of the company. Remember, we have a flag in the user object which represents whether the user is a CEO or not. Using the imperative style, the method code would look something like what is shown on the screen. Here we set the name only if the user is the CEO. So we need an additional check to test for that by using the method user.ceo, which will return true or false. The problem with this imperative style programming is that there are way too many cascading if statements, leading to undesirable code. We can replace that code by a nice Fluent combination of filter and map as follows. Here you see that after getting the optional user object, filter method can check if the user is a CEO. The filter method takes a predicate, and if at runtime this predicate returns true, then the filter returns the optional user object again. Otherwise, it will return an empty optional. The next step is to call the map method, which will return an optional string representing the username. If you call the map method on an empty optional, it will simply return back an empty optional. You can now begin to see that there is a distinct improvement in the readability of the code using the Fluent style of development. For sure, the Fluent style of programming does require some practice to get used to. Let's now talk about the flat map method, which is a variation of the map method. To appreciate this method, let's change the use case a bit. Let's say we would like to extract the zip code of the user instead of the username. So our first attempt in an imperative world would be to code as shown on the screen. Notice that the zip is actually within the address, which is within the user. Now this code works, but it's less than ideal for obvious reasons. There are too many if statements. We already know one way to eliminate the cascading if statements. That's by using the map method, as we see on the screen. Here we use the first map to extract the address, and then the second map to extract the zip. But what if we change the design of both user and address by adding two methods, getAddress and getZip, which returns the optional types? This is just to show how to deal with optionals. So in the record user, you have a getAddress. Now the record also has an address method which just simply returns an address. But the getAddress would return an optional address. I just added it to showcase the flat map method. Same with the address record. If a function which returns an optional type is passed to a map method, then the return result will be an optional of an optional type. The use of flat map will flatten the cascading optionals to just optional type and makes it easier to work with it. This is very similar to the flat map on the stream, where you have a stream of stream which is being flattened to a stream. So if we were to use the getAddress and the getZip methods instead of the address and the zip methods in our Fluent pipeline, we would end up with the following code. Notice the use of flat map methods. Method reference user : getAddress returns an optional address. But flat map would simply return the optional address, whereas map would have returned optional of an optional address. Bottom line, flat map should be used when the function passed to it returns an optional. Otherwise, use simply map. The optional class has a number of methods to consume the value from it. Broadly speaking, we can divide these methods into two types, the imperative style and the functional style. There are methods like isPresent or get, which can be used with a typical if-then-else style of programming. That's the imperative style of programming. More interesting are the functional and Fluent style methods. Some of the examples are shown on the screen: the map, the filter, the flat map, or else. One method among them, the optional.stream, seems a little bizarre at first glance. An optional object either has a value or does not have a value. Why on earth would we need to create a Java stream out of it? Let's analyze that a bit more. We know that Java Streams programming has been very popular among Java developers. It encourages a functional style of programming and makes the developer's job easy in many use cases which deal with collections. On the screen here, you see an example of a Java Stream pipeline. Here, a list of names who have valid addresses are extracted from a list of person objects. Such manipulation of collections is extremely straightforward using Java Streams, and it usually involves using the map and filter methods of the stream interface. Just like we can create a stream out of the collection, we can also create a stream out of an optional object. That's exactly what the optional.stream method is about. When the stream method is called on an optional object, it will return an empty stream if the optional is empty. It will return a stream of exactly one element if the optional has a value. Now at this point you might be wondering where such a stream could be used. Let me show you two idioms that can be applied to use this optional.stream method. Imagine that there is a users class which has a method called getUser, which returns a user object from a user ID. The method is not written with Java optional in mind. In other words, the method getUser is not returning an optional of user. It's returning the user object, and it could be null. The screen also shows an imperative style Java code used by a caller to retrieve the user object, and then take action on the user object by calling the handleUser method. But you also see something else. You can see several null checks that are made here. One to check the variable user ID, and then second to check the user variable. Now maybe there is a better way to handle this. The code on the left can be rewritten in functional style programming by using Java streams. Now here's where optional.stream method comes in handy. Now if you see the functional code, optional.offNullable is used to get an optional string object for user ID UID, and then a Java stream is created out of it by calling the optional.stream method. Now because UID is a string, we will ultimately get a stream of string objects, either 0 or 1 element. The map method of the stream is then called to get the user object by calling the users.getUser for that UID. And then the filter method of the stream is used to filter out null users. Remember, the getUser can actually return a null, so we need to filter them out. And then finally, for each method is used to handle the user by passing the method reference main : handle user. So even though the optional.stream is creating a stream of 0 or 1 element, it's useful in calling the handle user method in a functional style and finally eliminating the if statements. One thing to note here is that the map and the filter methods are called on the stream and not on the optional object. Optional class also has a map and filter. That is not being used here. It's easy to get confused about that. Now, I would not say if one style is better than the other, but you will see such functional style coding in the code base of many Java projects. The second idiom for using optional.stream is related to handling optional variables in the middle of the Java stream processing. Let's say that the users.getUser method returns an optional of user instead of user. In that case, we would have to take care of handling the optionals in some way. It will be verbose to use the optional methods like isPresent and get as a part of the stream processing. So instead, here's how we can use the optional.stream method along with the stream.flatMap method to handle this scenario. Let's analyze this code a bit. The map method returns a stream of optional user because getUser returns an optional user. Now flatMap method will take an optional user as input because that's available from the previous step. When we pass the method reference optional : stream to the flatMap, flatMap will internally call it and it will return a stream of user. Now here's one exercise for you. Think about how you can do this without using optional.stream and post it on the comment. It would be interesting to see the different results. Now, one thing to note in this solution is that we cannot call map instead of the flat map because otherwise the output will be stream of user. The call to flat map will essentially flatten the stream of user to a stream of user, making life much simpler for us. You can also combine the map and the flat map as shown on the right instead of using method references. Now you might find this easier to understand because here we are actually calling the stream method on the return optional user from the get user. Once again, note that the map and the flat map methods are called on the stream and not on the optional object. So final thoughts, many of the Java libraries return optional types as part of their method calls. So it is important that these optional objects can be easily integrated into the Java streams pipeline, which is heavily in use by developers today. And this should be done by minimal effort. Optional.stream method makes this integration possible.